Welcome to your video on indirect measurement. So before we begin, the first thing is to know what indirect measurement is. And to know what indirect is, you have to know what direct is. So direct measurement measures exactly what you're looking for. So you grab that ruler, you grab the scale, whatever it is, and you are weighing it exactly. Indirect measurement is when you can't do that. So like a building, no one can actually measure that with a ruler. That would take a very long time. So when there's indirect measurement, you can use a proportion to find what the measurement would be. So here's the first example. You have a fire hydrant that's 2.5 feet high that casts a shadow, a 5-foot shadow. How tall is the street light that casts a 26-foot shadow at the same time? So pictures are helpful. So here's a little fire hydrant, and that is 2.5 feet tall. And then there is a shadow that it casts, and that is a 5-foot long shadow. Okay, and then here's our triangle. And then we have a street light also. Okay, and that is casting a 26-foot shadow. And the question is asking how tall is the shadow. So we want to know how tall that is. So we are going to use a proportion, the height of each object over the shadow. Oops. Okay, so here we go. The height of the fire hydrant was 2.5, so 2.5 over its shadow, which was 5, and that will equal the height of the street light, which we don't know, so that's X, and then over the street light's shadow, which is 26. Now that we have a proportion, we can solve. Feel free to use your calculator, but you're gonna go from 5 to 26. So in order to do that, you take 26 divided by 5, and you will get 5.2. Remember, that does need to be an exact number. We're gonna go the same direction, so we do the same thing, multiplying by 5.2. And when you do the 2.5 times 5.2, you get X to equal 13. And then you want to make sure you label it. It's a real life situation. This is talking about feet. So the height of the light is 13 feet tall. Problem number 2, a triangle here, the distance of the line segment. So we have our triangle that we're comparing. So we're going to take the triangle CMS over the triangle RDS. So here it's helpful to draw it out two separately. So CMS is this triangle here. Okay, and that triangle has a height of 40, and then the hypotenuse is 320 there, so the longest side. The other triangle we have is RDS, which is the larger one here. And that triangle, the length here going all the way across, we don't know, just like we didn't know what it was on the shorter one. Okay, this length is different. And then we have a height of D. And then from R to S, we notice from R to C is 102, and from C to S is 320. So we have to take all of that together, add that up to get your length, which is 422. Okay, now the unknown lengths here, X and Y, don't really matter because we are finding the line segment R to D, which is represented with the letter D. So you can kind of ignore the fact that we don't know those two measurements. So here we go. So we are going to use the hypotenuse here and then the hypotenuse here. So CMS, the hypotenuse was 320. And for the hypotenuse for the bigger one, it was 422. And that will equal, starting with the red triangle, 40 over, and then the height of the green triangle is D. So now that we have our proportion set up, we can solve this. So going from 320 to 40, that's pretty easy math. You can see that you're dividing by 8. So you're going to do the same thing going the same direction, dividing by 8. And when you type that in your calculator, you will get D to equal 52.75. And then notice what your labeling is, miles. And there's your answer. Question number 3, a child 40 inches tall casts a 5-foot shadow. A nearby statue casts 50-foot shadow. How tall is the statue? So again, drawing a picture. Here's a little kid, 40 inches tall. Okay, and then that kid casts a shadow that is 5 feet tall. So here's your triangle. And then the statue is much taller. It casts a 50-foot shadow. And then this is inches, this is 50 feet. So this should be inches. Okay, so now to write our proportion, now that we have our two triangles, we're going to set this up so that we're talking about the height of the child over the shadow. So starting here, we have the height of the child, which is 40, over the shadow, which is 5. And then same thing for the statue. The height is what we don't know, so that's our variable. The shadow length there was 50. So then to solve this one, we're multiplying by 10. So our scale factor, remember that vocabulary word, scale factor is 10. And when we solve this, we get x to equal 400. And then our label there for the height was in inches. So 400 inches tall was the shadow, or that would convert to 33 feet and 4 inches. Last problem is on the back page. Here we have a picture. There's no words here, but we can figure this out. So talking about the height of a flagpole. So our proportion will be the height over then the shadow. So the height of the flagpole is what we don't know. Over the shadow, which in this one is 90 inches. Well, then we set up our proportion for the little girl. The height of the little girl is 54 inches, and the shadow on the little girl is 36 inches. Solving this proportion, if you simplify this fraction here, that will simplify to 3 over 2. And then simplifying makes this for easier math. From 2 to 90, you're multiplying by 45. So then you're going the same way, doing the same thing, multiplying by 45. 3 times 45 gives you x to equal 135 inches. You could convert that to feet also, just like I did in the last example.